All right, and finally, question 16. So in question 16, we are given a function f of xy. It is a cube root of uh, the product of xy. And there are two parts. So the first part is to use the definition of partial derivatives to find partial derivatives. And in the second part, we need to use the definition of the directional derivative to prove that basically directional derivatives don't exist except for the case when directional derivatives are along the x-axis or along the y-axis, in which case they are in fact just the same as partial derivatives, right? So this condition notice means that the direction here is not 1 0 and it is not 0 1, because in this condition, if the direction is just 1 0, then it means that the directional derivative is nothing else but the partial derivative with respect to x. And if the direction is 0 1, it just means that the directional derivative is the partial derivative with respect to y, right? So which is covered by part 1. All right, so let me explain how to do it. Now, first, we need to use the definition of partial derivatives to find partial derivatives with respect to x and y. Okay, so how do we find fx of 0, 0? So to do this, this is by definition is the following thing. So we take f, then we substitute 0 for y. It's going to be the function f of x and 0. And then we are going to differentiate it with respect to x. And then we will, after differentiation, we will let x be 0. Okay, so f of x0 is cube root of x times 0. Well, x times 0 is just 0, so its cube root is just 0. So this is the derivative of 0, and of course it's going to be just 0. All right, and same for y, I guess, because for f of y, what we do is we take, but now we've got to differentiate with respect to y, and what we do is we take our function cube root of x, y, and then we are going to replace x with 0. And then in the end we let y be 0, but it's still just the derivative of 0, and it's still just 0. Okay, so the first part is easy. How do we do the second part? Right, so the second part, in the second part we need to show that the directional derivative does not exist in any other direction. Well, so basically, yeah, since this is the directional derivative, so it means that at the same time a square plus b square should be 1. It is probably not important. I don't know. Yeah, at the moment I don't know whether it is going to be important or not, but that's just a part of the definition. So u should be a unit vector, which means its norm should be 1. Okay, it doesn't exist. So what we need to do is we've got to use the definition of the directional derivative, and here is the definition of the directional derivative, right? And so notice that this is, according to this definition, what we have is a limit. And maybe it's not really very easy to work with limits, so it is a little bit better to look at the following theorem and get kind of a hint from this theorem, right? So what we do here, so when we apply the definition, so what we essentially do, we introduce a new function, g of h. It is a little bit probably confusing because a and b in this lecture slide I used for a different thing than a and b in um, in this question, right? So specifically in the question, you have this 0 is really a, and this 0 is really b from the lecture, and this a is really u1, and this b is really u2 from the lecture. So this is in the lecture. Yeah, I guess it is a bit confusing, so I hope that you can kind of um, change it around a little bit and still understand what's going on. Right? So what we do, we introduce this function, and then we realize that this fraction is just the definition of g prime of 0. And I think it's just easier to do that, so than to apply the definition of the derivative. Okay, so let me do this method instead of just directly applying the definition. Right, so what I do here, I am going to introduce this new function g of h, and this new function g of h is going to be, well, uh, basically f of 0 plus ah and 0 plus bh, which is going to be what is cube root of um, ah times bh. All right, so which is, I guess, so there is a constant, so a and b are constant, so this is cube root of ab times h. This is cube root of h square, and cube root of h square is really h to the power 2/3. Right, so this is my function g of h, and again, if you look at this boxed formula, then what I need to do, I need to find g prime of 0. So the directional derivative du f of 0, 0 is essentially by definition. So this is actually the definition too. So this by definition is g prime of 0. Right, so what I need to do, I need to take my function and differentiate it with respect to h, and take the derivative with when h is 0. So it is going to be, so let me just try d over dh. Then I'm going to copy the function, cube root of ab, then h to the power 2/3. So I need to take this, and then I need to apply to substitute h is 0. Okay, so let me just do this derivative. So this is a constant, so cube root of ab times h to the power 2/3. So when I differentiate it, I'm going to get 2/3 times h to the power minus 1/3. And then I need to substitute h that is equal to 0. Right, but then h to the power minus 1/3 is essentially division by h, right? I mean, so you can write this as 1 over h to the power 1/3. And the power 1/3 is just cube root. So you can also rewrite it as 1 over cube root h. But then if you let h be 0, then you will have a division by 0, so which is essentially infinity. Right? So it means that, well, when you get infinity, essentially you just say that the derivative does not exist, right? So which is why it doesn't exist. Doesn't exist. Okay, so that's all, and that was the last question of the tutorial, so I hope it helped.